All right, hey everybody, grab a seat. We're gonna get going here because I have the slot before lunch, and some of you might be getting hangry towards the end of the presentation. So I figure if I don't start soon, there could be a mob scene. So this presentation is Stop Expecting Magic Fairy Dust. Make your app secure by design. And this presentation, as you'll see in a minute, is really all about giving you guys stories and tying things back to concrete, to reality, and frankly, to awful mistakes. So I'm Patrick Walsh. I'm the CEO of Iron Core Labs, and I've spent the last 15 years of my career building enterprise applications and security solutions and leading engineering teams doing those things. So I have some credibility in this area. I've built network security firewalls, intrusion prevention. I've built, I was on the Right Now team here in Bozeman, or at least I was here from Boulder, Colorado. So the first story I wanted to start you guys off with is a bank heist back in 1854 in Sweden at Östergötland Bank, which I probably murdered that name. It's a notable bank robbery for a couple of reasons. One of which is they basically didn't have bank robbery laws, so the guys eventually got caught, but they got a slap on the wrist. It was like 3 months, and one guy got sent to America. The other reason it's notable is because it was the largest bank heist in history up to that point, and held that record for over 100 years until the 1960s with the Great Train Robbery. So let me set the scene for this. The bank building was secured with a locked door and a kind of a secure outer building. And inside they had a bank vault. And the bank vault itself was sort of state-of-the-art for the time, with this incredible state-of-the-art lock that was pick-proof. So these two guys come along and they said, I wonder if we can get in there. And well, it turns out they could, and pretty easily, because the bank employees didn't each have copies of the key. So instead, they hung the stupid key on a secret hook outside the bank. So these guys, they found the hook, they found the key, and they just let themselves in at night. Then they went to the vault, this super expensive, lock-proof thing. And they looked at it and they said, turns out those hinges are on the outside, and they're not very secure. And they took a hammer and they knocked off the hinges and they opened the door backwards. And that's how one of the largest bank heists in history, at least for many, many years, happened. So what can we learn from this, and why am I bothering to tell you guys about a bank heist at a computer conference? Well, I think it's kind of instructive for a couple of reasons. Because when you think about security, oftentimes many organizations, many people think about it in terms of features. Oh, we'll prioritize two-factor somewhere on our backlog or something like that. And you should go add two-factor to your app if you don't have it. But that's not how you should think about security. When you think about it as features, you've lost the ability to think about it as a secure system. And that's what happened here, right? Someone focused on the lock, and they made this great feature of a great lock, and they didn't look at the system. They didn't think about the hinges when they built that vault. And that was a huge miss. And that's the thing that I'm going to try and save you guys from here today with a lot of examples and maybe a little bit of shaming of some companies. So when we talk about secure design, it is the thing that you must do to create a secure application. As secure as you can get it, at least. And this is super important in today's day and age. When you design an application, there's a lot of considerations. Forget designing an application. When you design a feature, when you design any element of the system that you're building, there's a bunch of things that are inherently extremely important, right? You have to design for performance and scalability, usability, reliability, and maintainability. Maybe there's others. But there's also security in there. And security is, to me, extremely important in that if you spend your time thinking about usability or scalability, but you didn't spend time thinking about security, you've totally blown it. When I say security, what I specifically mean here are the three kind of main pieces of that. Confidentiality, which is to say, making sure someone doesn't get access to data they shouldn't be able to see. That means integrity, which means making sure someone can't change data they shouldn't be able to change. And availability, which means someone shouldn't be able to knock you offline or crash your app on purpose. So these are the things that we're optimizing for when we talk about secure by design. So let me ask a question to the room. In your organizations, who's responsible for security? Who is responsible for their budget? Just yell it out.
Me.
Who? secret. I thought everyone? Well, that's true. Who has control of the budget for security? Not everyone, no. In fact, in most organizations, it's IT. It's usually the CISO or the CIO. And that's sort of an interesting thing, right? Because engineering rarely gets security budget. The security budget goes to IT, and as a consequence, the tools that are available to them, the tool chain available to IT is basically perimeter security stuff, right? It's firewall, it's antivirus, intrusion prevention, VPN, those kinds of things. And those are all good, but it's kind of a very narrow piece of the puzzle. And if you think about an application that has a bug in it, and a flaw and that bug is maybe some kind of critical security flaw, well, it really can't be fixed from the outside. There's no intrusion prevention that's going to predict and stop someone from exploiting a bug that's specific to your application. So, and by the way, that perimeter is by design full of holes. Like you can't, if you made a wall all the way around your stuff that had no way to get in and out of, it would be a prison, not a network. And so the whole point, unless you have a totally offline network, which few people actually hit that level of anything these days, then that doesn't exist. Now, if you had a perfectly secure piece of code, if you could write that code, you designed it well, and you didn't make any mistakes in coding it up, you wouldn't need a perimeter. But I have yet to meet the perfect programmer. And even if I did, I guarantee that if they wrote a perfect, flaw-free application, they're still using probably third-party libraries, probably a third-party web server, probably at a minimum, third-party operating systems. And those operating systems, those libraries, those perimeters, it's an entire fragile chain of trust, and every one of them has security flaws. So there's no way to write an application that is perfectly secure. Or even if you did, it really isn't, So ultimately we do both, right? Perimeter, and we secure the application. No code runs in isolation. So from the IT perspective, IT has to assume that the application is totally flawed, the developer screwed it up, and it's got all these things that can hack it. And from the other side, from the dev perspective, which we're going to talk about mostly today, you have to assume the network is compromised. It's dirty. It's full of people who shouldn't be there. And by the way, it probably is. Like, these are both good assumptions because they're probably almost always true. So, secure design principles. What is principle? What is a principle? It's a rule or a belief governing behavior, and it's a fundamental quality or attribute. It's an essence, right? It's something that is, but most importantly, the thing I'm trying to get across here is that it's something that's pervasive. And it should pervade every one of your decisions that you make as you code software. So today we're going to go through 10 different security principles. Now, there's a bunch of different organizations that have different kind of secure by design security principles. OWASP is a big one. They have 10. NIST has something like 33 of them or something, depending on where you look. So I pulled together my own, and I named them the way I think it makes sense. I put the OWASP where there are OWASP equivalents to what I'm talking about, or that overlap heavily. I put their names in there, but I don't think they name things well, so you'll see why. So let me give you a story. First, so this story is about a smart light bulb. Sylvania Lightify by Awesome is a popular, it's got 4 stars on the App Store, connected light, you can change the colors and so forth. Kind of cool. But they call it a smart connected light for the smart home. That always kind of sticks in my craw a little bit because I'm like, what do they mean smart? A light bulb that's smart? Well, I actually looked up the definition of smart. Quick-witted intelligence, or clean, neat, and well-dressed as an adjective, or as a noun, intelligence and acumen, or sharp, stinging pain. Yeah, maybe you saw where I was going with that. Aha! It's smarts! Now I get it. So let's talk about these guys, because it's a poop show. So the first one is cross-site scripting. So some of you know that cross-site scripting is when if someone puts in like a script tag into an input on a form, it gets reflected back and then it runs that script, which is bad because then it has privileges to do things within the context of the application in many cases. In their case, their username wasn't validated. You could put in any kind of script, any username, and it would pop up on the screen. So that's not so great. SSL, from the phone to the light bulb, is a SSL connection. Great, but they didn't validate their certificate. meaning anyone could intercept that and inject their own certificate, pretend to be the light bulb, and no problem. It's accepted, which means anyone can intercept that. Malicious Wi-Fi network name. This is cool. It's kind of like the username thing. It's the same deal. If someone makes a Wi-Fi network with a script tag in it, guess what the light bulbs do? Not good things. So, next one is they have pre-shared keys. But instead of randomly generating a pre-shared key, for one thing, even having a pre-shared key is something I don't love, but instead of having a random number there, they just put in like 1, 2, 3, 4, 5, 6, 7, 8, 9. The guys who tested this thing, it took them about an hour to crack that, so not very good. There were like 6 other really serious issues, but I don't want to go into them. What I want to do is I want to pick out, there's a lot of things these guys could have done better, but I'll just pick out a couple. And the first one, and this to me is like one of the most important principles, and it may be obvious in some ways, and a lot of these maybe are when you look at them, but it's one of those things that you should kind of keep in mind always, 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 and that's verify everything. OWASP calls it complete mediation. When we talk about verifying everything, the first thing is inputs from users. And always you want to have whitelists, not blacklists. It's not like, oh, the angle bracket character is bad. If you do that, I guarantee they'll find another way to hack you. You think, what should be in a username that we would feel like is worth accepting? Whitelist, regular expression. And the other thing that this applies to is that SSL certificate, right? You're making an SSL connection, verify everything. Verify the certificate. Or pin the thing, which means you have a copy of what you expect the server's public key to be, and you actually verify it that way. That's the best. So in our case study here, those are a couple of things that they should have done. They should have been verifying those inputs. As a side note on this, a lot of times developers end up turning off the SSL verification because in testing in QA environments or localhost, they don't have a valid cert, and then it gets out to production that way. So that, once upon a time I kind of understood that, but these days Let's Encrypt gives you free certificates. Like you can just generate a certificate as often as much as you need. That costs you nothing, so there's literally no excuse anymore for like fake certificates and things that don't validate. The other one that we'll point out for these guys is what I'm calling expect transparency. The inverse of this is security by obscurity. If you're assuming that no one's going to find out how you do this thing over here, and that's like the foundation for your security, you've got a real problem. You should, when you design systems, just assume that people are going to be able to see every part of it and know how you did it in depth. And in this case, what that really means is like that pre-shared key. Like they're like, oh, no one will find our pre. It's okay if we like do a weak key here. No, like people find stuff. There's different ways of getting access to that. So no obscurity. That by the way was I think last year. OneLogin is from last week. So OneLogin is a security company, and they're basically a password manager. But in addition to being a standard password manager where they hold on to users' passwords so it can be looked up, they also hold things like OAuth tokens. And what this does is it allows someone to log into OneLogin and then be automatically logged into all their cloud services like Google Drive or whatever. And businesses use that because then they can control access to all of these different services where they can shut down kind of access all at once across a bunch of services. So that's cool. And they do a lot of security blogging and so forth, and so that's why I've got my little security and security up there, because security people and companies are also susceptible to making security mistakes. And it happens, and we won't shame them too much, but in this case what happened was someone got a hold, we don't know how, but of the AWS keys. That gave them access to the server, their AWS servers. And that person got into those servers and was like, cool. They were there for like 8 hours, but the company announced, hey, customer data was compromised, including the ability to decrypt encrypted data. Well, that's kind of interesting, right? Because what the implication there is, it's like, great, they actually locked the desk drawer, and then they put the key like on the desk right next to it, right? So in this scenario, what happened was they did encrypt stuff, but they didn't protect the keys, so someone getting onto the server was able to get both. And the way this happened was, let me talk you through their architecture a little bit. So they use It's called a shared secret symmetric AES key to lock that. They have one per user, and they use that to lock that each user's passwords and tokens. And then they had a master encryption key to lock each of the keys of each of the users. Well, both of those things were on the server so that when the hacker got in, it was trivial for them to do a two-step decryption of every user's data. So that's what happened with one login. So what lessons can we learn from that? Well, one security principle that would have helped them a lot was layers. Building security in layers, or defense in depth, as it's much more frequently referred to. In this case, okay, great. There's this single gate to get into the server, and there was no second gate to get access to the user's data. So that was a problem, and something that I'm sure they're looking at really closely right now. One other note on this, which is that it's pretty useful to think about it in terms of different access methods. So when you have two gates in a row and they're like the same lock and the same keys, right? That's not really adding a layer. So the trade-off on this is that you get a little bit less code reuse, you get a little more complexity, but when you vary up your things of the different layers, it's going to make it more secure overall. Because people have to find different ways to surmount your obstacles. The other principle that I'll bring up here for this particular case is the what-if game. That's what I call it. The weakest link is what OWASP calls it. And the thing is, when you're designing something, you just sit there and say, preferably with a few people around the table, like, what if someone got a hold of our AWS keys? Or, what if someone got into the server? Like, what would happen then? That would have been exceptionally useful for these guys to think through and maybe plan for up front. I think this is probably one of the most useful principles to do that what-if game in a security context. All right, Netgear. How many of you in this room have Netgear routers at home or at your office? Raise your hands. Quite a few. Okay. So in December of this year, there was a nice little vulnerability discovered, and the exploit was published. It looks like this. Put in the IP address of the Netgear router /CGI bin, semicolon, any command you want to run. Right? By the way, that command gets run as root. Netgear routers are Linux boxes. So that was discovered in December. DHS, the Department of Homeland Security, had one of the most interesting responses to this I've ever seen in a notification. It basically said, disconnect your Netgear devices until there's a patch, and you get it updated. Then it said, or if you don't want to do that, use the exploit to kill the HTTP server until the next reboot. Kind of cool, right? Now, I'm gonna shame some of you here. How many of you have patched your Netgear routers since January when they released a patch for this? Like 2. So there's something like 30% of the room raised their hands when I asked how many people have Netgear routers. I saw like 2 people raise their hands. So, you have homework now. Those of you. So this really brings us to an important point. Netgear doesn't have automatic updates. They can't security patch their stuff. It basically requires a sophisticated user to go do a firmware upgrade on the damn thing. Oops. So, what security principle might have been smart for them to think about? In this case, the one I'm going to call out, there's a bunch. And for almost all of these, there's probably like 5 out of 10 or more that would have applied to the thing, but I'm using these to leverage specific points. In this case, what I call distrust users and services. I think a healthy amount of distrust is really, really good in security. It's kind of the point. This is also sometimes called the principle of least privilege. And in this case, there's a couple of things, but the biggest one to me is that they were running HTTPD as root. Right? You should never run a service as root. And it's so freaking convenient because if you run stuff as root, there's never any problems, right? If everything's running with administrator privileges, everything works great. The beauty of that is it's also really, really convenient, not just for you, but for anyone who's attacking your stuff, right? And so it gets back to layers and other things. But the principle of least privilege is super important. It comes into place in a lot of ways. You think about limiting permissions to users. It can get really hard when you start creating permission systems, and it makes everything really much more complex. But the idea of really restricting down to the base needed and expanding out from there instead of starting with everything and trying to chip away, it just works much better, especially if you start that way from the beginning. How many people have heard about the Mirai botnet? Yeah, this one was in the news quite a lot. last year, basically last summer, but if you're paying attention, it's still going gangbusters. Hasn't been used in a while to take things down, but there's like a botnet war out there taking control between a few different botnets. Mirai means the future in Japanese, which is kind of horrifying because I don't think it's wrong. So the thing about the Mirai botnet, what this was someone wrote a fairly crappy and not very good little worm to just scan the internet for devices and try to log into them with one of 60 common usernames and passwords. And turns out that little technique is pretty effective. They ended up weaponizing IP cameras and home routers and DVRs and a whole bunch of things. And then they used all of those to send tons of traffic to specific websites and just knock down things off the internet. So Brian Krebs, kind of a big security researcher, security journalist, his site was knocked offline with like one of the biggest denial of service attacks ever. Akamai dropped him as a customer because they're like, dude, we're out, we can't handle this. Luckily Google picked him up. They also knocked off Dyn DNS and ended up taking things like Netflix offline on the East Coast on a Friday night. And so, people were a little upset. It's probably why you heard about it. So this one, the principle I'll call out here is secure by default. So all of those things that had default usernames and passwords, that's not a good idea, right? And it's not just that. It's like out of the box, if you want to make things as secure as possible. So what should these Internet of Things smart manufacturers done? They should have set it up so that their thing couldn't go online until someone went through a setup process and set a password. So, that sounds like, oh, that's a usability trade-off, and it can be. Like secure defaults can be a usability trade-off, but you can work at that. It doesn't have to be. It doesn't have to be a big one anyway. And on this note, I have another story for you. It's actually really similar. You'll see the similarities here in a second. MongoDB, 5th most popular database in the world, #1 most popular NoSQL database. It's kind of this free-for-all database, which sort of fits with the story I'm about to tell. For a long time, when you installed MongoDB and you started it, it would listen across all of your ports. So not just on local hosts, but across everything, including the public ones, right? And by default, no access control, no authentication. So the way they set it up was, it's like, hey, read the manual, and when you go to production, go through the manual and go through the steps to set up security. Turns out, people don't like to read manuals, and that usability barrier was pretty high for people. Consequently, there's some 680 terabytes of MongoDB data open and available on the internet. Think about that for a second. And so people started going, that's pretty low-hanging fruit. There's this way to monetize other people's data that we figured out called ransomware. Let's just go scanning for that stuff and we'll go lock it up. And some 30,000 databases to date have been locked with little, hey, we just encrypted your data. If you want to ever see it again, pay us. Desktop ransomware, usually they do unlock it if you pay them. These guys, most of them didn't. So, oops. That's something that will haunt MongoDB forever. They eventually fix that, but they can't fix what's out there. So for this one, I'm going to talk about user-friendly. So obviously, there's a bunch of other principles we've already talked about that tie in, like secure defaults, but usability is why MongoDB set it up like that. We want to make it super simple for someone to get started with, no barriers. And that's great, and they've had a lot of success, and maybe some of that is because of how easy it is to get started with. But had they forced that step of, hey, let's just assume a secure default, have we done this? I don't think it would have been less usable, right? It would have just forced the steps for moving it to production. In my opinion, the trade-off in usability, they were just moving the shell a little bit. So to my way of thinking, they actually had bad usability in this case by forcing people to read the manual to make it secure. I'm doing good on time. All right. Next one. Some of you may have heard this one too. It was kind of big in 2015, and then again in 2016 when they updated their research. A couple of guys had some fun hacking a Jeep. It was noteworthy because a Wired reporter went out driving it and said, okay, hack it while I'm driving it. And then he got on the freeway and then they killed the transmission. So it was kind of a screw up in journalism and security reporting in some ways, but it got a lot of attention, so maybe not. The thing about the Jeep, and by the way, you could say this about airplanes and a number of systems, is that there's a real strong separation of systems between the information entertainment system, which in the case of the Jeep was internet connected. So there's like a Sprint cellular link that's always on to the internet in there, so you could do things like streaming music to your car, right? Stuff like that. And then there's the driving controls in that system. And they're strongly separated, they tell us, but it turns out that's logically separated. They're physically connected. So these guys figured out how to hack the entertainment console and then how to get from there in their original thing into the diagnostics stuff so that they could take control of the car in some ways in some circumstances. And then the following year, last year in 2016, they figured out more impressive ways of basically disabling all the security checks. There was these systems that watch to make sure no invalid messages go through, and they figured out how to disable those systems, and then they could send anything they wanted. And they moved into a realm of being able to trigger things like cruise control and steering. So it's a little bit frightening when you start thinking about connecting cars to the internet, and it's happening a lot right now. So this gives, the principle that they were trying to hit was separation of duties or separation of responsibilities, or what I'll call compartmentalized stuff. As much as possible, you want to disentangle systems. Now, the case of the Jeep is sort of extreme, right? Like, obviously, you should separate those things. And, in hindsight, they probably should have been physically separate in that case because it's so critical, and they're sadly not. But compartmentalization applies to just general software design also. Like, especially, people are doing lots of microservices and things these days. Like, as much as possible, you want to make those things standalone from the standpoint of security, from trust, from you don't want to make it so easy that if someone gets into one thing, they can just jump to the next, right? And that's what often happens. Let's see if I missed anything on that. Yeah, make your stuff modular, one system, one purpose. So the thing about that is it does lead to more complexity. It's harder to troubleshoot things and to QA them when they're not all the same, right? It's the same thing that before we talked about dry, and when you compartmentalize, it makes your job a little bit harder to maintain and a little bit harder to develop in this case. You can design against that, but it's extra work. But this is an extremely useful principle, and I bet you've heard of separation of privileges before because it's one of those ones that comes up all the time. Okay. Let's talk about OpenSSL for a minute, because this is something that I would wager everyone is using in their apps one way or another, whether they know it or not. And all of you are using every day as consumers of the technology just by using your web browser. OpenSSL powers something like 65% of the internet. It's a library that's been around forever and ever, and it's a crypto library that powers like HTTPS. So the thing about OpenSSL is it supports a lot of different algorithms. And combinations of algorithms, like, oh yeah, we can do this type of encryption with this type of hash and mix and match. And oh, by the way, it supports a ton of different operating systems. They have like 4 active versions. If you go and you look at like what's affected, it's like 1.1.0 C and 1.0.1 J, and they maintain all of those. It's ridiculous how many things they have to maintain. The matrix of combinations of crypto algorithms and operating systems and architectures is nuts. And their code, by the way, is old crufty C code with go-to statements in it. Kid you not. So the combinatorics is huge there, and you can kind of see the outcome of that if you look at the vulnerabilities that have cropped up over the last few years. It's really skyrocketing, and some of these you may have heard of. Heartbleed and Freak and Logjam were all kind of these, in the last few years, people started branding vulnerabilities when they found them for whatever reason. It's kind of annoying, but makes it so you probably remember it too. Most all of these vulnerabilities come down to either like old algorithms that date back to the 90s, back when security was regulated, or when encryption was regulated and had to be like weakened on purpose. Some of it comes down to just complexities of interactions of those systems that no one had really tested, and the fact that their test coverage is under 50%. But OpenSSL. What could make OpenSSL better? Well, keep it simple, stupid. It's like probably the best thing ever. And I'm going to go into like deep depth on this because it sounds, saying keep it simple sounds simple, but it's really not, and it's really hard to do. OWASP calls this economy of mechanism because they don't like to say things succinctly for some reason. But the thing with keeping it simple is one place that you'll see this a lot is legacy. So let's say you have a SOAP interface at your company, and you're like, that's been around forever, we need to replace that. Let's make like a nice RESTful JSON API instead. All right, you go build that, you deploy it, great, it's working. What happens to the old SOAP interface? I'd argue 9 times out of 10 it stays there forever because you're afraid of what'll break if you shut it down, right? Almost everyone in here is laughing. You've been through this, right? And then that crap accrues, but no one's looking at that for years. And so now that code is like 10 years old, and you know, who knows what's using it, and that's a huge, oops, oh yeah, security for the win. And that's a huge security issue. So when we talk about keeping it simple, one thing is, like, don't leave legacy code hanging around. If you can't sit there and think through your system, like, and understand it all and keep it in your head at one time, there's no way you can make that secure. Think about that for a second. Do you actually think you can understand the security of your system if you can't understand your freaking system? Right? So when I say keep it simple, and people are like, oh, but it does so many things now, you know, it's grown so big, we have so much stuff. I came from Right Now, I remember this, you know. Some of you also might. It builds up, but that is the enemy of security. Big time. Keep it simple. You can, next time you're pushing to get rid of some legacy thing, use the security argument. Geez, sorry guys. And that leads me to the last principle, and I don't have a story for this one, but monitor. And this one, by the way, doesn't have an OWASP equivalent, but to me, this is super important. And NIST and others call this one out also with different names, but if you're not audit logging what's going on in your system, if you're not tracking things and logging them, and by the way, logging, it's like when we talked about earlier, hey, I locked a drawer with an encryption key and I put the key on the server right next to the encrypted stuff, like that doesn't sound that smart. Well, it turns out logging on the same system isn't super smart either. You should probably send those logs elsewhere because it's pretty easy to modify logs that are just local and mutable. So monitor systems, audit the crap out of it. If something goes wrong, one, you might detect that something is going wrong if someone's watching those logs, which is part of monitoring. It's not just logging the stuff, it's like watching the logs. And two, when it comes to monitoring, if something goes wrong, you can figure out what went wrong. What did someone access? Like, what did they get access to? How did they get in? Like, if you're not instrumenting the shit out of your application, you're definitely screwing it up from a security standpoint, and probably a whole bunch of others as well. So that's my 10th principle. And I'll flash all 10 up there one more time and we'll just talk about it again. Layers, verify everything. Play the what-if game. Expect transparency. Distrust users and services. And by the way, even your admins. Compartmentalize. Keep it simple. Keep it usable. Make it secure by default. And monitor everything. Thanks.